As we look at example 8, you can see from the heading that we're looking at independent probability. So going back to the vocabulary page, we are told that the probability of A and B is equal to the probability of A, times the probability of B. So in example 8, it says we're going to roll a die twice. Remember we said that rolling dice were independent events because the first result does not affect the second. So the question is, what is the probability that you get a 2 on the first roll and then a number greater than 4 on the second roll? And it has an and here, so we want to make sure we're setting it up that way. So we want to find the probability of 2 on the first roll and greater than 4 on the second roll. And so to set that up, we're going to first find the probability of rolling a 2. And then we're going to find the probability of rolling a number greater than 4. And then we'll multiply those together. So on a 6-sided die, which we always assume it's going to be 6-sided unless we're told otherwise, on a 6-sided die, each number appears once. So the probability of rolling a 2, there's 1 2 out of 6 sides. So that is a 1 in 6 possibility. The probability of rolling a number that is greater than 4 is still going to be out of 6. There's still 6 choices. But there's only 2 numbers that are greater than 4, and that's 5 and 6. So we have 2 in 6 chance of that occurring. You absolutely can reduce your fractions either by reducing vertically or cross-canceling if you'd like to. For this first one though, I'm just going to go ahead and multiply straight across. So 1 times 2 is 2, 6 times 6 is 36, and that would reduce down to 1/18. And if I put 1/18 into my calculator, just a reminder on your calculator, if you have one of these, we can use this ABC key as our fraction key. So we would do 1/18, and then we can use our F to D key here to convert it to a decimal, and that's going to give us this repeating decimal. So we're going to estimate that to be approximately 0.056 or 5.6%. The next question is asking us to prove whether or not there's an independent relationship. They've given us all the pieces, and it's our job to see whether or not this is true. So we're going to set this problem up by plugging in what we know and then testing the math. So the probability of A and B, we're told here, is 5.6. So if we did 5.6, and that's coming from here, it should, if they're independent, it should equal the probability of A, which we're told is 0.7, times the probability of B, which we are told is 0.8. And then when we do that math, 5.6 at this point would just stay the same. We're going to leave it alone. And we're going to go ahead and multiply these two numbers together. And again, you can do that with a calculator if you need to. We should know 7 times 8 is 56, but the question is how many decimal places. So just a reminder, if there's 2 numbers behind the decimal here, there have to be 2 numbers behind the decimal here. Okay? These numbers are not the same. And since they are not the same, these are not independent. Okay, I'm going to pause it here so you guys can try examples H and I. Okay, hopefully you got that work done so you can check your answers here. When we come down here to examples H and I, when we do the math on H, we find they are independent, and when we do the math on I, we find they are not. Alrighty guys, that's the end of this one.